Awesome. Thank you so much, everyone, for joining Pittsburgh Jog this awesome Thursday evening. I'm Sirisha. I've got Renata as well, and together we host these monthly sessions. And typically we try to do these the second Thursday of each month. So it just worked out pretty well for us, and we're hoping to just keep that same rhythm going on. And if you want to learn more about our events and what's coming up next, you should follow us on the Pittsburgh Java Meetup group, which is where you found us today. And you'll hear more about upcoming events right there. And if you're a tweeter, then you can also follow us at that handle, PG@Java Meetup, because we post news about Java in general, because we follow other Java user groups, we follow other Jug leaders, we follow just leaders like Jose in the industry. So we get to share all that news as well. So definitely follow us there if you are a tweeter. We do not have the next speaker confirmed. It is still work in progress, but one quick announcement. We do have a YouTube channel now, and our 2021 and 2022 recordings, which has just been the one session so far, is all up on our YouTube channel, and you can subscribe to it. That's our channel name. And with that, I am going to hand it off to our awesome speaker today. Jose, if you want to quickly introduce yourself, and you can take it away, and I will stop sharing.
Great, thank you, Sirisha, for the introduction, and thank you for the invitation to this session. I'm super excited to be virtually here. I would be even happier if we could all be in the same room and exchange and communicate directly. But okay, Zoom is not too bad. Yeah. I'm going to try to do something super hard but extremely useful. Share my screen, which should be working now. So hopefully you're seeing the first slide of this presentation about the future of Java, which is not completely the future because records, we already have them. Sealed types, it should really be called sealed types, in fact. We also already have them, and pattern matching, we're going to talk about it because it's something that will be added piece by piece to the Java language, to the JDK. That it started already, but it's not completely done yet, and there are many more things to come in this matter. All right, so here are, oops, it's not working, please. Here are the several links with the technical content that I like to publish on the internet. You have my GitHub account, several YouTube channels. I'm part of the Java developer group as a Java developer advocate at Oracle, and we are handling a Java channel on YouTube that just reached 100,000 subscribers a few weeks ago. I also have my own channel, which is this one, and I'm publishing kind of a series every 3 weeks, 4 weeks, called the Jeb Cafe, which takes a specific topic of the Java language and well, deep dive with the code example and this kind of thing. If you're interested in Java technology, you may find useful to follow this. And with the release of Java 17, I guess you're already aware that Java 17 has been released about 6 months ago. We also opened with the Java Platform Group a new website, which is called devs.java, which is now the place you want to connect if you need information and documentation about the Java platform. This is the welcome page, currently maybe a little old, of this awesome website. And if you have any comments on it, please share them on Twitter or whatever, so that we can fix any issues you may find with this website. Right. So Java 17, why is Java 17 something that you should be as a Java developer interested in? Well, it's just for this reason. This chart that looks like some kind of Pac-Man-like figure shows, in fact, the spread of Java 8 and Java 11 applications around the world. Now, it's not very accurate. It's roughly between 2/3 and 3/4 for Java 8 and the rest for Java 11. Now, you may be wondering, but what happened to 9 and 10? And because Java 17 has been released, there also must be 12, 13, 14, etc. And what happened to them? Well, it turned out that these versions are not really used. They're probably used by some people, but the proportion of these people is so low that it doesn't appear on this chart. And what you can correlate this event to another event. It's just Java 8 and Java 11 are both LTS versions, long-term support versions. And 17 is also an LTS version. So we can expect that in a few months or a few years from now, the spreading of Java 8, 11, and 17 will look like this one. Right? We can expect that Java 17 is going to be adopted by application. And in fact, it already started. We can already see a fair amount of applications that are moving, that have moved, or that are in the process of moving to Java 17. Java 11 will probably lower its share, and Java 8 also lower its share just to make room to Java 17. So because Java 17 is an LTS version, well, it's probably a good idea to understand what's in it and what you can do with it. By the way, the next LTS should be the Java 21 version that is in, I was about to say in 2 years from now, but it's not 2 years from now, it's 18 months from now, 1 year and a half from now, September 2024, if I'm not mistaken, yes, 2023, because 21 is the next LTS that we are going to have. So maybe we can expect that the version of Java in 3 years from now will look like this chart. Hopefully Java 8 will go smaller and smaller and will disappear, leaving room for 11, 17, and 21. So that's the gist, in fact, for this Java 17 version. Now, if you're still running a Java 8 application, here is a list. I think it's almost complete of everything, of the new things that you have between 8 and 17. And as you can see, they are not just language features. There are also tools, libraries, and improvements of the JVM. One of the biggest improvements maybe is the introduction of a new garbage collector, ZGC. Now, as a developer, there is very little chance that you will ever interact directly with this garbage collector. But what you can remember is that it brings really new performances for your Java application. Performances that basically you get for free, because if you move from 8 or 11 to 17, you get this new garbage collector that will going to give you new performances, and you don't have anything to do. You don't have to touch your code to get these performances, which is really awesome. I would just like to point another stuff that is really great and that will give you performance for free, which are those two things, the last items of the language, compact string and indify string concatenation. Now, compact string means that your string of character, your string class, really, which has been wrapping an array of chars since the very beginning of Java, since Java 1, little more than 25 years ago. This array is now an array of bytes, meaning that if you are processing a lot of JSON or XML or this kind of string of characters, magically, your string of characters are going to divide the amount of memory they need by a factor of 2 if you're using regular 7-bit characters, which is really awesome. And you get that for free. You don't have to change your code. You don't have anything to do. You just, boom, have a factor of 2 in the memory consumption, less pressure on the garbage collector, and everything. And the other one, indify string concatenation, is the fact that string concatenation has now been optimized. It's implemented. The implementation is based on the use of invoke dynamic and some kind of class that is doing some magic behind the scene, and it's kind of the same. Now, if you need to recompile your code to leverage that one, but you just recompile your code using this new feature. You don't have anything to do, and magically you can have up to a factor of 5 in the performances of your string concatenation, and it's the same for string formatting and this kind of thing. So this is really great. This is the kind of thing that you just get for free when you move from one version of the JDK to the other. Now we are going to see what you can do that you could not do with 8 or 11. So this kind of thing, you are not going to get them for free. You will have to write some code to get these new features. So before we start, I would like to start with a word of warning. There are two things that you need to stop doing in your Java code. The first one is you should not call the constructors, these constructors of the wrapper classes that you have, that are the classes like integers, double, float, character, etc., because they are going to be removed. Why are they going to be removed? It's part of a project of one of the 5 biggest projects of the JDK that is currently under work, which is the Valhalla project. Valhalla will bring a new concept to the Java language, which is the concept of value class. And the value class is just a value. It cannot have an identity. And if you have this kind of constructor in a wrapper class that is going to become a value class with Valhalla, then you will have a problem. So instead of doing that, instead of calling this constructor, you can just call this factory method that has been around for quite a while now. Many people are already doing that. You should really do that. I mean, if you don't do that now, it's not too bad. It's not a problem. Your application will continue to work. But when Valhalla is there, and when you will be in a situation where you will have to take Valhalla because it will be in an upcoming version of the JDK, then you will have to grep your code and remove all these calls to these constructors and replace them with the static code. So as of now, you can safely stop calling these constructors and call the factory method instead. So that's the first word of warning. The second one is about the finalize method of the object class. Now, finalize method has been used since the very beginning, very first versions of Java, and it's already deprecated and is going to be removed. So you should stop using it. That's as simple as that. There are many issues with this method. Most of the time when you put code in this method, this code is buggy. And you don't necessarily know why, but it is buggy. For instance, there is something that is not specified with this method, which is which thread is going to call this method. This method is called when the JVM knows that your object is going to be garbage at some point in the future. Now, this method will be called, but you don't know when it's going to be called. It may be called, in fact, quite far away in the future. And this may cause problem to your applications. The thread that is going to call this method is unknown. Well, it's known, but it's not specified. So you may end up with race conditions if you put some code in this method. For instance, suppose you have an array list in your class and you just call list.clear in the finalize method. Well, it turns out that the threads that are going to add elements to your list are not the same as the thread that is going to call the clear method on it. So you may have a race condition. The same goes for hash maps, by the way. And in that case, if you look at the code of the clear method, both from array list and from hash map, you will see that a race condition can raise a null pointer exception. So you may have a null pointer exception because of that, without any kind of anything you can do against that. So of course it's not a very good idea to do that. So you shouldn't call this kind of method in a finite method. Now the second use of the finite method, very often seen, is the call to close methods of, for instance, files or output streams or input streams, IO resources. Now, if you do that, you may run into the first problem I just talked about earlier, which is that if you have a lot of memory, okay, your objects are going to be garbage, but it may be, you may see the situation where in fact the JVM is not calling your finalize method because it doesn't need to effectively garbage the objects. And if it's the case, you may find yourself in a situation where you are opening many files and never really closing them. You wrote the close method in a finalize method, right? But because the JVM is not calling them, your files remain open, and you may have a resource leaking with that. And the more memory you have in your application, the more this situation can occur. So you shouldn't do that. If you have some resources to close in a class, then the best pattern that you can use is to implement auto-closable in that class, and pass the instances of this class to a try with resources pattern. This is a pattern that has been around since Java 7. I guess you know it already, and this is perfectly secure. If you do that, then your resources will be properly closed and at the right time. So yes, those are the two main bugs that you have in a finalize method. So the gist is, don't put any code in finalize, because in the end it will not be called anymore. So don't do that. Those were the two words of warning I wanted to give you before going to the real content of the talk. So we're going to talk about records, and I would like to place record in a larger context, which is the context of pattern matching. This is a small subset of the several new stuff that have been added to the JDK since the JDK 11, right? Now, probably some of them you never heard about them, like nestmates or constant dynamic, and you don't really, or even in classes in private in VM, by the way. And don't worry, it's absolutely not a problem if you never heard about them. You can perfectly live with it. But all these different elements are in fact different pieces that are going to come together, and that have been added to serve the implementation of pattern matching in Java. We already have several elements of pattern matching. In 16, the pattern matching for instance of has been added to the language. And in 17, we have a first preview of the pattern matching for switch, and the second preview in 18. So we can hope to have it as a final feature in 19, which is to be released in September. And we also should have probably what is called record on array pattern matching, that is deconstruction, record deconstruction in the 19th release. We don't have it in 18. I guess several people hope to have it in 18, but it was not the case. So, but we should have it now for 19. All these elements, pattern matching, are developed under the umbrella of the Amber project. Now it's a reference. Maybe the older people among us remember this cycle, the cycle of the Amber Chronicles. I think it was published in the 80s or something like that. I guess that Smalltalk developers may remember the great book of Amber. I don't know if we have Smalltalk developers in the audience.
You know, there's one here.
Oh, Don, I didn't see you. Okay, and you know what? I'm going to switch to the IDE, because I think that the best way to talk about pattern matching is, yeah, Smalltalk developer equals Don Rab. Well, I know other Smalltalk developers, by the way, but yeah. Okay, so you should be seeing my IDE now, hopefully. If it's not, it means that I did the right thing. Okay, it's good, great. And before I'm talking about records, I just would like to show you just a few things about a very cool feature. Now, I'm not going to put that on slides because it doesn't make any sense. This is a string of character, right? And if I run it, you can see that, yeah, it does just what you think it is. Now, what I can do, starting with Java 17, well, before that, but it's put a triple double quote here, and right after my triple double quote, add a carriage return. And if I run this code again, well, you can see that it's still a string of characters. Now, this string of character, starting with 17, is called the text block, in fact. And you see that I can as well add a carriage return here, and as many carriage return as I need. And if I run this code, you can see that in fact the carriage returns have been kept in a string, just because this is how text blocks are working. And even if I add some character that should be escaped in a normal string, I'm not going to escape them, and you can see that they have been kept in text block. By the way, if you still want to escape them, it's okay. You can also escape them. So if you want to refactor your whole string of character to text block without having to unescape everything, you can do that, which is very convenient. Of course, if you don't have that, there's absolutely no need to escape them. Yeah, I don't know if you can see that, but you see that this is IntelliJ I'm using. IntelliJ added a vertical green bar right before my text blocks. And in fact, you can see that everything that is to the left of this green bar has not been kept by the compiler, but everything that is to the right of this green bar is going to be kept. Okay, there are in fact two kinds of blank spaces before my string of character here. There are these blank spaces that have been added by the IDE for indentation purposes, and these are called incidental white spaces in the documentation. And all the rest that is to the right of this green bar are real blank spaces that are kept by the compiler. And this is very convenient. And in fact, the limit is the position of this closing triple double quote. That is, if I put this one right here, you can see that this green bar has been moved. I can still format my stuff using the shortcut from IntelliJ. But you can see that this part of the text block has been kept, has not been modified by IntelliJ. Only the part to the right, to the left has been modified. And if I run it like that, you will see that it has been kept. Right. Now, what I can do also, let me put this here, maybe here. What I can do also is decide to impose the presence of blank spaces to the right of my elements of characters of this text block. I'm going just to do that by adding a \s here. Now, if I want to see them, I'm going to transform this message a little. So message, yeah, sorry, thank you. By the way, I have a new method on the string class, which is called lines, that creates a stream of string, cutting my text block, my string of characters, not only a text block, on the carriage returns. And I can map them, taking each line, let me call that line, and adding something like that, and something like that at the end of it. And I'm going to put this in a list. Okay, and this is going to be my lines. By the way, this toList method is also a new method from the stream API. It creates just a list from the elements of the stream. So you could see that as a replacement of the collectors toList traditional call. Now, this list is unmodifiable. So if you do not modify it, you can just replace your calls to collectors toList without any problem. If you plan to modify it in the future, then you cannot, of course. And I could do something like that, or I could have done it directly on the stream, by the way, never mind. All right, so if I just run this code, you will see that the blank characters to the right have also been kept by the compiler, thanks to this \s that I've added. So that's the text block. It's not a great thing, but it's just super great to have that. If you have what's the idea behind that? The idea is just to add any kind of SQL request, JSON code, XML elements, this kind of thing inside strings of character without having to concatenate each line or to add any kind of escape character in it. So it's just something super great to have. Can we do string interpolation? So not for the moment. String interpolation is when you want to do this kind of thing. You can do that in many languages. Okay, and here you want to do, I don't know, this kind of stuff. And what you want, of course, is this $i here to be replaced by the value 10. Let me put 10 here. Okay. Of course, if I run this code, it's not working. So string interpolation is not in the JDK as of now, but it's the next step in the string enhancement program. Let me call it in that way. It's part of the Ember project, and if you check the documentations on the Ember project, you will see that there are currently work on the way to bring string interpolation to the language. So that's the next step. We don't have it yet. You're welcome. All right. Please, if you have any questions, just ask them as I'm speaking, because okay, we are not 200 people in the room, so I'm very happy to answer them to you. All right. So let us move to the records now that we saw that. So I just created a record here. You see, I called it range because why not? And that's a record. Okay, a record is a very simple piece of code. I just created here. Let's see if this code is working. It's just Java 17, right? It's a local record. It has been created within a method. By the way, you can create classes within methods. If I write this kind of thing, that's a class, and I can create local classes to methods. Okay. There is something, so there are two things that are particular to record. First, it's declared with the record keyword, which is kind of the same as a class keyword. The record keywords means that this class is in fact a record, and it means several things. The first one is that this class is going to extend the record class, just like enum extend and then a special class from the JDK, which is the enum class. And second, this class is final. So you cannot extend anything with this record. If I try to write this kind of thing, for instance, it will not compile. And you cannot extend a record because it's a final element. The second thing is that when you declare a record, you need to add this stuff to the declaration. Okay, and these stuff are called the components of the records. And this component stuff is really a new concept within the JDK that has several consequences, and we're going to see them. Oh, sorry, there is a question about text block. I believe formatted was added recently, so you could do a text block with formatted instead of doing string format. Yes, I guess so. I'm not sure, but it's I think it's a fair assumption to say that. Yeah. So, okay. So yeah, those are the components of the records, and these components are in fact the state that this record is carrying. You see, you cannot add instance field to a record. If I try to do that, I will have a compiler error telling me instance field is not allowed in the record. So the only way to add state to a record is really to declare its component here. And when you do that, the compiler is going to give you several things. First, it's going to give you a constructor that I'm calling here, right here. Okay. It's also going to give you a toString method, and I just I can see that this toString method is working there. It's not written there, but the compiler also creates an equal and an hashcode method based on the value of these components. And it also creates accessors. Now, accessors for this record are end method and begin method. They do not follow the Java Bean stuff. It's not get end and get begin, but if you need these methods, you can perfectly add them to the record because you are free to add as many instance methods as you need to this record. So you can also create a get end here and return this data. Okay, the begin and the end fields are private final fields created for me in this record, so I do not need to write them, but I can still use them if I need. So that's great. Now this component, I told you that it was a real concept in the language. That is, if you check the reflection API on the class, there is a method isRecord, and you can get the components from this record with a get components method that returns an array of components. And the same goes for the annotation. You can specify an annotation that it can be added on a record. You see, when you create an annotation, you have this target stuff. You can put an annotation on the type, on the field, on the method, on many elements of your Java code. Now you can also put annotations on the components of a record. So this component stuff is really something. Now, these components here are the only state that you can have in a record. Because a record cannot extend anything, cannot be extended, and cannot have instance fields, all the states you can have in a record are in fact the components of this record. And a record can only be built by calling its canonical constructor. This canonical constructor is there. I can write it if I want, like this one. Can IntelliJ, yeah, generate this code for me. This is the case. Why aren't you happy? Because it's not public? Is that it? No. Sorry, because it's range and not record. All right. And this is the constructor that the compiler is creating for you, and you can write this constructor by hand if you want. Yes, thank you. As long as you're correctly creating this component, I can put a 0 value if I want here, which is not maybe not the greatest idea, but I can do that. But if I forget to initialize one of the components, I will have a compiler error telling me, hey, you didn't do your job, right? Now, if you want to create another constructor, it's perfectly possible, but this constructor has to call the canonical constructor. You see, if I create this constructor like that and properly initialize the values of the components of the record, I will still have a compiler error telling me that I did not call the canonical constructor. Okay, so the right way to write this other constructor is this one, just like that. Another compiler is happy. And if the compiler is happy, I am happy too, because I like my compiler to be happy. All right. So this is something super important to understand. You cannot create a record, you cannot build a record instance without calling the canonical constructor. Now, why would you want to write explicitly the canonical constructor? Well, there are two things that you may want to do. The first thing is defensive copy. Suppose that this record is built on a list or on an array that is a modifiable element, and you want to prevent someone to modify this element once it has been added to the state of your record. You can do that by creating a defensive copy in the canonical constructor. And it's the same for the accessor. You can also explicitly write the accessor of your components. Why so? Because you also want to be able to provide defensive copies of the internal state of your record if you need that. And the second reason, beside defensive copy, is of course validation. For instance, here, if I want to say that begin should be lesser than n, so if begin is greater than n, then I want to throw a new illegal argument exception. Begin end is greater than begin. Greater. Graded. Okay. Oops. Okay. Then this is also a reason why you would like to you may want to write your own canonical constructor. Now, if what you have to do is only validation, then what you can do is remove this declaration here of the components and remove the initialization of them. And this is still working on compiling, as you can see, and this condensed version of the canonical constructor is called the compact constructor. A compact constructor is a constructor in which you do not declare the components, and then the compiler will add for you the copy of this, of the arguments of this constructor to the internal state of your record. So it gives you something that is really super simple and super easy to manipulate, and also super readable. I mean, what is a record? What is a range? It's just created on begin and end, and if begin is greater than end, then your range is not valid, which is really great. Now, record can implement any kind of interface. So suppose I want to implement iterable. This is a range, iterable of integer. Can you add the method for me? Yes, the iterator method. Thank you. And now I'm going to return a new iterator of integer. I don't need you. And I'm going to create the index starting with begin. As I have next value if index is lesser than end. By the way, this is the one. And this is the one. And in next, I'm going to return, I don't know, something like index plus plus. Okay. So now I have a range that is iterable. I can iterate over it. So I can even write it in that way. Range for int index in range, and I'm going to just write the result. And now I have all the indexes that have been displayed. So that's the gist of a record. Pretty simple, very easy to use, very easy to write, and very easy to manipulate. I would like to show you one more thing, because you may be thinking about something that is, I just told you that there is no way you can create a record, instantiate a record without calling this canonical constructor. Now, you may be aware that of a point in Java, which is there is a way to create instances of classes without calling any constructor, which is deserialization. And I just would like to show you an example. I already wrote the code, okay? I have two classes. A first class that is the range class, and that is basically the class you would have written before having records, okay? And the same class, sorry, where is it? Just here. The same stuff written with a record, and both implement serializable. Now, what I'm going to do is the following. I'm going to create a range record. First, I'm going to, a range class, precisely. I want to make it a class. And I'm going to comment out the validation rule, okay? And I'm going to serialize this class and put it, in a file, range class, blah, blah, blah. Let me run this code. I'm going to run properly. Okay, so I just create a range class, which is in fact a corrupted object because the validation rule was not added. Now I have a bug report. Hey, you forgot to put your validation rule, so I'm going to fix it. Oops, no more bug. But now what I'm going to do is try to deserialize the rand objects that I just serialized in this file. If I run this code, you can see that despite the fact that I added this validation rule to my class, this corrupted object has been deserialized, and now I have to deal with a corrupted object in my application, which is really a security breach that is very annoying. With records, you cannot have that anymore. Because remember, a record is always created by calling its canonical constructor. So I'm going to do the same thing just to show you. That's a record. I'm going to serialize it in a record file. And I'm going to comment out this compact constructor. So now I have a record without any validation rule. Let me run this code again. Range record, yes, that's it. Okay. So now I'm creating a corrupted record in this file, right? Bug report, you forgot your validation rule. Let me fix it. Done. It's not too hard. And now I'm going to try to deserialize this record. Okay, I put it in this class, reading range. So let me try to deserialize this stuff. And because even in the deserialization process, a record is always created with by calling its canonical constructor, this object has not been deserialized because it did not pass the validation rule I put in this canonical constructor. So that's a security breach that records are fixing, and that is only fixed with records. That is, if you're using record-like objects with Lombok, for instance, well, Lombok, in fact, under the hood, gives you a final class that is a classical Java class. It does not give you a record. Maybe they will do that at some point, but it's not the case yet. So if you are using Lombok objects, you will not have this security breach fixed. So that's it. That's the gist for record. I just would like to show you very quickly what you can do on a little kata with records to improve the quality of your code. Now, I know that I have a kata companion in the audience that is also a Smalltalk developer.
Don, again. Moving on.
I was like leaving it to chance with those clues.
So Don, I'm going to work under your control, right? I call this kata the city kata. It's really not a great kata, but I like it because I like simple things. So it's just I've got a file with a set of cities in it, right? And for each city, I have some kind of ID. I'm not going to use. There is the name of the city, the name of the state in which this city is, the population of the city, and the area of the city, the land area of the city that I'm not going to use neither. Okay. And we are going to play with that. So I already wrote some code to properly read, because it's a CSV file, right? Each city is on one line. So I wrote some code to analyze each line of the file. And now I have, and I created a record, sorry, with the ID, the name, the state, the population on the surface, even if I'm not going to use everything. And now we can play with this. You see, we have a little more than 300 cities, which is nice. We can put the states in a set. Let me do that, or in a list. Okay, so it's just a job for the Stream API. And I'm pretty sure that, Donald, that you'll be able to write it with a collection framework, with the Eclipse collection, sorry. So that will be a nice kata fight next time we'll meet. So stream, and I'm going to map that to the state. Okay. Call this thing probably, and call to list, because I'm not going to mutate this list. And this is a list of string, and I'm going to call it cities. Okay. Oh, cities, states, not cities. Right. And I'm not going to write all the list of the states. I'm mostly going to maybe just write the size. Yeah, and that's the number of states. How many states do we have in this file? I don't think we have them all. We have 46. No, not too bad. And now if I want to have the populations of all the states, that's another job for the collection, for the Eclipse collections. So I need to collect this and to regroup this by state. So that's a good job for my good friend, the grouping by collector. I'm going to regroup that by state. Okay. And I want to sum the population of each city. Remember, this is a stream of city. So that's, I got a collector especially for that, which is the collectors summing int. And here I can just take the population of each city. Great. And this is a map, because the grouping by collector produces maps. The key, the state, is the state. So the state is a string of character. And I summed up this population, so the value is our integers. And this is an histogram, in fact. It is the population by state. Okay. I could ask for the size of this map, which should be the same as the number of states, which is 46. Great. And now what I want to do is just extract the most populated state. So to do that, it's another job for the Stream API or for the Eclipse Collections framework. Oops. Great. So I'm going to stream the entry set of this stuff. Now I have a stream of map entry of string and integer, and I want to take the max. Map entry, and I want to take the max by value. So I got a comparator directly on the map entry interface. This is going to return an optional. This optional cannot be empty because the map is not empty. So taking a max of a non-empty set always give you a value. So this is going to be a map entry of string and integer. And this is the most populated state along with the population. Okay. So let me print out the result. And given this this file, the most populated state is California with a little more than 19 million people living in it. It's only known by the cities that they are in the file, so it's only the most populated cities in the states, not all the state, of course. Now, if you take a look at this code, you see, I could make it, in fact, completely unreadable. And it's very easy to make it completely unreadable. I can just rename this with map, okay, and rename this with entry. And now we are completely lost. How do I know what I'm manipulating here with this line of code? Okay, it's just a map entry of string or integer, and I know that it is a state on the population, but it's clearly not written in this code. And this is very bad. You see, there are two legs for clean code. First, having meaningful variable names, which is an effort that we always should be doing. But the second leg is even better, is also having meaningful type name. And here my types are just string for the state and integer for the populations. So my types are absolutely not meaningful. They do not give me any kind of information. And by the way, this code here, entry set, stream, map entry, comparing by value, is a completely generic code. You could apply this code on any kind of map that you have, as long as your values are comparable, and it will give you the same. So this is very bad, because this code that is absolutely not readable will lead you to very hard to maintain code in the long run. So how can you make it more readable? Well, we have record for that. The good news is that we have a solution to improve the readability of your code. You see, for instance, this string here is a state. Okay, so I'm going to say, okay, this is not a string of character anymore, it's just a state. And guess what? I'm going to make it a record. I got my record city here. I'm going to say, okay, this is a state, and a state is known by its name. Why can I do that? Because a record is almost free. My record is created. It's just here, and I do not need to put it in another file to expose it to my application. It can be completely private to my processing here. Now, if I want to make my code compile, because of course this code is not compiling anymore, I need to refactor this code here. So this state there is not a string anymore, it's a state. Great. So that's the state. I need to change it there. Now this code here is compiling properly. And all I need to do is say that this map is in fact a map of state and integer, and this map entry is a map entry of state and integer. Is this code still compiling? Well, it is still compiling, but it also gives me the same result, which is even better, of course. All right, so that's for the state. I can try to do the same for the population. Say, okay, this is not an integer anymore, this is a population. But for population, it's a little more tricky, and we're going to see how you can do that. So the state is really super simple. Now, this is my population, and it wraps, in fact, an int. I can call it number. Okay. I'm just going to do the same. That is here. This population is in fact population. Okay, and this is, oh, sorry, it's here. New population. Just like that. So now my record city is fixed. This code does not use population, so it's okay. Now I have a slight problem here because this population is not an int anymore, and this summing int is expecting an int. That's going to be a problem. And here my comparing by value is also not compiling anymore because the value here, I could put it here. The value is a population, and my population is not comparable. But we can fix that. It's not too bad. Now I have a city, and what I get is the population and the number. Okay, so now I have an int again. I just need now what I get here is a map of state and integer. This collector returns an int, but I need to wrap that in a population object. If I want to have a population here, I have a collector for that, which is the collectors collecting and then. So I'm going to first collect with this and then create a population, wrap the result in a population. Why aren't you happy? Because there is one closing stuff that is missing. And now my map is correct. Okay. Now this comparing by value is a little more tricky because what I really need is to compare population elements. So what I could do really is follow the patterns that is suggested here, that is adding a comparator in a factory method. So what I could do is population. Oh, sorry, I'm not going to do it in that way. What I can do first is say that this entry set, I'm going to map it in a populated state, new, which is another record, okay, that is going to wrap the state and the population. And I'm going to do it here, record populated state. It wraps the state and the population. Okay, and to create, to map this stream of entry sets, which is the element I want to wrap, I need to create this constructor that takes the entry as a parameter. So populated state, I'm going to take a map entry of state, sorry, and population. So this is the entry of my stream. And remember that this constructor should call the canonical constructor of my record. So here I'm going to just call get key and oops, and get value. And now my code is compiling properly. And now what I want to take is the max of this stuff, and I'm going to use exactly the same pattern as this one, that is create a factory method to compare populated states. And now I'm not going to say I want to compare that by value, but I want to compare that by population. Okay, so now I can just create this method there, I don't need you. And you are going to compare just this populated state by population. By the way, I had it directly. Okay. Now, this is not compiling because this population element is not comparable. But let me just make it comparable real quick. Of population. And just need to add a very simple method, which is the compare to method. The other here. And what I'm really comparing are integers. So integers that compare this number, is it? Yeah. Other dot number. And now my code should be compiling almost, because this is a populated state. It's not a map entry of population anymore. Great. Is it working? I guess it should be working. I probably should work a little on the toString methods, because now since I've wrapped everything in record, it's a little, the display, the way it's displayed is a little more complex. But I could fix that. What I can also try to fix is this collector here, because this collector is really in a way. I'm going to put it in a variable. I think I did not. Oh, what did it do? Sorry. Yeah, okay. I'm going to put that in a variable. Yeah, I call it downstream. Well, I'm not going to keep this variable, so never mind. And I'm going to say that this collector should really be returned probably, I don't know, grouping by. Oh, maybe I should. Yeah, no, this was okay. Collector collecting, and then maybe I should call it population summing or something, and move this there and this factory method here. Return this and hide this collector. User are here, and I don't need you anymore. Right, where were you used? Here. Okay, so now my collect is just grouping by city, state, and population summing. I could have put it also on the city record, saying city summing by population or something like that. It would probably have been a good idea too. But you can see that just by placing records in key points of your code, you can greatly improve the readability of your code. Now we are not using generic objects and generic algorithm, generic method code anymore. We are really using meaningful types thanks to the user of records. So for me, this is really a great way to make your code much more readable. And by the way, all we have done here is we have used composition, right? If you check this code here, for instance, the population stuff, it's just built on a number. You could see that as an extension of the int. Of course, you cannot extend ints, but in the Gang of Four, people are telling you you should favor the composition over inheritance, and this is exactly the right example to show that. Now, this is what you can do with record. I would like to show you one more thing, unless you have questions. I'm still monitoring the discussion stuff, but I didn't see any questions, so that's fine. But if you have questions, please, by all means, bring them on. Oops. Here I have a shape interface, and we're going to use records a little more. Here I have a shape interface, okay, and this shape interface is implemented with several elements. Well, it's going to be implemented with several elements, which are this square record, this rectangle, and this circle record. Okay. Well, I'm going to add this implement stuff because it really should be here. Implements shape. Great. Same for rectangle. Oh gosh. And same for circle. Okay, and now I'm in a situation where I would like to add some, let's say, business processes to my shape. Now it's going to be super simple, so maybe it's a little pedantic to talk about that. But you see, if I want to compute the surface of my shape, I probably can add a method something like surface. Okay, this is the classical way of doing that. In Java, right? You add methods to an interface, and why are you doing that? Well, just for one reason, which is clear here, is that we have three. Okay, let's show that. We have three classes here that are that have been declared as implementations of shape, and because I didn't add any the right method on this circle record, I have a compiler error. Now, this is extremely useful because if you have several implementations of a single interface in your application and you want to add or remove elements to this interface, then the compiler will help you, telling you, hey, you need to add implementation here, here, and there, which is great. Now, what is the downside of this? What is the price to pay when you are adding stuff to your interface, to this interface? Well, suppose you're just dealing with a complex object model, and if every time you need to add some kind of feature on your object model, the solution you choose is to add a method on your interface. It means that at the end of the day, after 3 or 5 years of work on this object model, you will probably be ending up with like 50 methods or even more methods on your interface and on your object model. And your object model is going to become super complex, bloated with many methods that you are not going to be able to remove, because if this object model is shared by all the business modules of your application, once you have added something to it, it's super hard to remove anything. Why are you doing that? Really, it's just because the compiler is there to help. What could be the alternative to that? The alternative to that would be, okay, I'm not going to add it here, but in fact, this shape method, I'm just going to use it in a single business module of my application. So what I really should be doing is this kind of thing: create a method. Let me put it. Do I need make it public? Public int as a surface, okay, and it's going to take a shape as a parameter. Okay. Right, I'm going to say return 0 just for the compiler to be happy. And now if I decide to do it in that way, because I didn't want to modify this interface, well, all I can do is something like that. If shape is an instance of square, then I'm going to return shape dot edge times shape dot edge, and if it's a rectangle, so I'm going to do the same. If shape instance of rectangle, what I'm going to return is shape dot 8 times shape dot width. Okay. I'm going to suppose, I think I made the circle an implementation of shape, so I'm going to remove this like that. So suppose I have only 2 implementations of this. Now, I think that we all agree that this code is not the greatest code you've ever seen. It has been improved slightly in Java 17, because here what you can do is add the declaration of a variable there, and you can use this variable directly within your code. Now, you may be thinking, oh, this is very nice syntactic sugar. which it is. But it's in fact a new concept to the JVM, which is called the pattern matching for instance of, right? This is not a type anymore, it's something else. And it's not a declaration of a variable neither. It's in fact a pattern. It's a type pattern, and a type pattern comes with a type and with a binding variable, here square, that is created if what's to the left of the instance of operator matches what is there to the right. It's really great to have that, and this square variable is available anywhere. It's okay to use it. So I could say, okay, if square dot edge greater than 0, I could use it there. I couldn't use it if I had a or boolean here. Of course, it wouldn't make sense to have that. So here I have a compiler error. Doesn't make sense. Okay, but with the and the boolean operation, it's okay to do that. Now, this code is a little better with the pattern matching for instance of, but it's still not that great. I have only 2 implementation of my shape interface, but I still need to add this return 0 here just because it's the language is working like that. By the way, I could make it a switch because switch became an expression starting with Java 17. So I can switch on shape. Remember, previously I was only able to switch on integer types and not the long type, string of characters and enumerations. And now I can switch on types, which is really great. And I can also mix that with pattern matching. Say that if this shape is in fact a square, then I want to return that. Now in Java 17, it's a preview feature. So I need to activate the preview feature within my IDE. So don't use that in your application yet because it's not final, right? Here I can return directly on this one. I can do the same with the rectangle. Put the rectangle here, put this code there, and then get rid of this. Great. And now I need the default stuff saying, okay, I want to return 0, which is the equivalent of my return 0 at the end of the if statement. Now this is slightly better. It's probably more readable. Well, I like it in that way, but I still have this default there, which is in fact not needed because I have only 2 implementations of my shape interface, but the compiler doesn't know that. For the compiler to know that, I need to add another feature to this shape interface, shape interface, which is the fact that this interface is in fact sealed. If I tell the compiler that this shape interface is sealed and that the only permitted classes are square and rectangle, okay, which is allowed because square is indeed an implementation of shape and rectangle also, then in my switch here, I do not need this default. See, the compiler is telling me this default branch is not necessary anymore, which is great. So now if I add in this shape the circle type, okay, it does not compile because so far it does not implement interface, the shape, sorry. So let me add that. And then you can see that at this point here, the compiler will tell me that this switch expression is not covering all possible values. So with seal types, switch on types, which is this pattern, and records, I could have been using regular classes, by the way. I can get the feature I had previously with the interface is that if I want to add something where I need some implementation, the compiler will tell me. But I do not need to put it at the interface level now. I can put it outside of this interface. And so all the features I need to add, I needed to add on this interface can now be added outside of this interface without cluttering it. And this is really a great feature. I am going to add this circle there. Radius, and I need to take the square of this radius. Okay, and because this surface returns an int, I'm going to say that pi is equal to 2, and I will be happy, and the compiler will be happy with that. Okay, so this is in a nutshell what pattern matching for switch is about. It's about adding behavior to a hierarchy of classes or types from outside of this hierarchy. It does exactly the same job as the visitor pattern. If you think pattern-wise, it does exactly the same job without having to have this accept method and visit method that you never have on any kind of model object anyway. So it's better to have it in that way. Now, I would like to talk a little more about pattern matching, unless you have questions, but I don't see any questions. No? Okay. I would like to talk more about pattern matching, and for that I'm going to go back to the slides because unfortunately the rest of the code I'm going to show you does not compile because it's not even a preview feature. So, oh, there is a question. Feel free to ask your question here. Absolutely. Thank you, Sirisha. I'm going to share the slides again. Where are they? Where are my slides? My slides are here. So you should be seeing my slides again. I'm going to jump. The next step in pattern matching is called deconstruction, right? We just wrote this code just a few minutes ago. The next step will be to write this kind of code. Okay. We know that a record is built on components. So if you write this kind of thing, the binding variables will be the components of the record directly, and you'll be able to use them as such. Okay. And the same will go for pattern matching for switch. You'll also be able to use that in the pattern matching for switch, so that using pattern matching along with deconstruction in this kind of stuff, which is really awesome. Along with the record deconstruction, we'll also have array pattern matching. And array pattern matching is about saying that if O is an instance of an array of string, you will be able to write it in that way. That is having directly the deconstruction by telling that, yes, the elements of the array are going to be strings of character. And by the way, you could also do that with records. That is, if you have an array of circles, you can also deconstruct the records at the same time and have the binding variable, which are directly the components of these records, which is absolutely awesome. Deconstruction is great, but the first step will be only about records and components. But even for records, you can also create records along with factory method. For instance, you could have this kind of thing. Okay, so will you be able to deconstruct records that have been created using factory method? Well, the answer is yes. It's in the plan, and the plan is to be able to write this kind of thing. Okay, directly call the kind of factory method like syntax. Of course, it's a pattern, so it's not a factory method anymore. This is not a factory method, this is a pattern. You could read it as if area is a shape that has been built by calling shape.circle, passing this radius as a parameter, as an argument, then deconstruct this for me. And if this becomes possible, then you will also be able to use directly deconstructors from regular classes instead of just record. You can see here that you have the same signature for this deconstructor. Now, this is not going to be called deconstructor, of course. This is just for the slide. It will be another syntax, but if you have the same signature as a record, as the constructor, those are binding variables, okay, and they are the same. You could see that as an external state description of your plain old Java object, which will allow both overloading, that is having several constructors and several deconstructors, and a defensive copy. For the deconstructor, what you have here is in fact the output of the pattern matching. The output is not the written stuff; it's the contrary. It looks like the arguments, right? So you saw the pattern matching with instance of and switch. We could imagine also having a match keyword, which could be used in that way. Some kind of keyword that would work the same as the a if keyword. You see, if this shape matches circle, center, radius equal shape. So this is the statement. In fact, then center and radius will become binding variables that are going to be created and used in the scope where it makes sense. If it's not the case, then you can either throw an illegal state exception, or maybe give values, default values to those binding variables, to these binding variables, so that you can use them in the rest of your code. And of course, you will be able to use match with more than one pattern, because why not? Okay, and even nest pattern with this match keyword, which is great. Some more example with the factory method. Okay, so you could deconstruct an optional using that. We opened an optional in the record in the little kata that we did together.
Jose, I do have one
but
question.
For that there's a question. Yes, of course.
I have a question. So for the previous slide, were you saying that these are already part of Java 17 features, or is this something that's going to be coming up? I missed that part.
No. If it was part of Java 17, I would have showed it in the IDE.
Yeah.
If it's in the slide, it's because it's not working at all.
Okay.
It's not even a preview feature. This is from a we could say a white book or white article that is available in the Ember project documentation. Okay. So it's not something that I have taken from my hat, but it's really something that is underway. People are working on that. Brian is working on that. Brian and Gavin are working on that.
Okay, that's good to know. Thank you.
So but this is the kind of pattern that you will have. Max is the binding variable, but you could also imagine having this kind of pattern, which is also great, right? Because string.format is also a factory method now, so you could also do some kind of deconstruction with them. And you see, you have nested deconstruction here because the argument of the %d is in fact integer.valueOf, and this is also a pattern, right? To deconstruct the integer, the string you get, valueOf returns the string, you deconstruct the string you get to extract the int binding variable from this string of character. So this is in fact a parse int. There is some kind of parsing behind the scene. Okay, you can create maps with factory method. So if you can do that, then you can deconstruct them. Okay, and write this kind of thing. And if you're able to write this kind of thing, it means that you can also say, okay, if this map has been built with the key name, then deconstruct it and bind name to the value bound to this key, and do the same for email. And then you just can use name and email directly within the rest of the code. Okay, but you can also do that with this kind of stuff. This is the JSON file, of course, and you can write it. You can create it using factory methods. So if you can write it using factory method, it means that if you write this kind of code, now this AND is some kind of Boolean operator between patterns. It's not the regular AND Boolean AND that you use in Boolean expressions. But then this is just one instance of one line of code. This is just one pattern built on the use of factory methods, and it just extracts all the binding variables for you in just one pass. Now, just take a minute and imagine the amount of code you need to write to analyze a JSON file at the moment, right? You have a lot of validations to do, a lot of stuff to extract, even some conversion between string of characters and integers and int, even dates, this kind of thing. Here it's just handled for you by pattern matching. And the last step could be if one day we have map literals or collections literals in Java, which is something that other languages have, then we could also imagine having pattern matching for literal and be able to write this kind of thing, which would be really awesome. Well, this is far away in a future that may never happen. So don't take my word for that. Okay, but this would be really super great to have that. Right. So what do we have so far? We have constant patterns. Okay, we just check the operand with the constant value, and this is what I showed you. We have type patterns, which is the pattern matching for instance of and the pattern matching in switch. All right. Pattern plus var, pattern plus deconstruction, method, var, etc. All this lies somewhere in the future, a future that may never come, but hopefully it will. Where are we so far? We have pattern matching, for instance, of as a final feature in the JDK 17. Pattern matching for switch is a preview feature in 17 and will be the second preview feature in 18 when it's released in 2 weeks from now, I think now. Record and array pattern matching supposedly will be a preview feature in 19. Match and literals, this is far away in the future. And this is what I wanted to tell you about pattern matching. And we still have some time for questions if people have any questions.
Actually, Jose, I was like forcing myself to be quiet. But I did,
please.
I wanted to go back to
Sure.
your, if folks don't mind, go back to your example with the population.
Okay, you want to see the IDE again?
Yeah, because you did something, I think, and I think it's really cool, and it actually allows you to handle a potential issue that comes about from using one of the collectors.
It's this one. Tell me.
Yeah, so because you actually did the summing here, for the code that you were writing, you wouldn't actually have to change this, but when you do summing int, right? Summing int will overflow when you hit max int value, right? So unlike counting, which returns a long, right? This returns an int. If your population was to, I guess, exceed, 2+ billion, right? You start hitting, let's say, population of the world, you'd have a potential issue, and it would actually go hidden, right? You wouldn't know about it because it would just silently overflow. Now, the nice thing is because you broke out all the records like this, you could actually fix that inside of here, right? Actually getting the sum without having to worry about the lossiness. And I don't know if you would just use summing long, I guess is probably the easiest thing, right?
If you think that you are not going to overflow with longs, I think that you could just replace this with a parse long. Okay, wrap population. You want me to do that? I think
I was more worried about the sum than the individual, because assuming, like, once again, an individual population didn't exceed 2 to the,
Yeah, but since population, where is it? I lost it. Since population wraps an int, even if I sum on the long here, it will be cast to an int at the end of the day. So it may even be a compiler issue if I do that.
Yeah, will that work?
I don't think this one would, but no, it doesn't work. It doesn't work because number. Oh no, because number is an integer, and this is expecting a too long function. So I'm not even sure that it's not compiling because of that. You see, this is not the right type. It's a too long function. It's supposed to be a too long function.
Okay, I mean, we can't just, so why, I'm confused though, like what is population returning that it's going red?
And the compiler is lost because of the boxing and this stuff like that. I think that the right way to put it is to say that this population, if you're afraid of overflow, you need to wrap a long.
Actually put it as a long?
I think. So if I put a long here, now I can say this is something long.
Right.
Okay. But
then you have to do long compare. You can't do integer compare.
Yeah, absolutely.
Is that everything?
Yeah, it's everything because the parse int here will be silently cast to a long.
Yeah.
I should really call parse long doesn't.
You gotta be long. It's gotta be long long class, not integer. Yeah, on the left there,
Right.
yeah.
Yeah, absolutely. Thank you. So that would be cleaner to do that, and I think that's it. And I think
Okay,
that's
but I
it.
guess the point I was trying to make is like the other code that you wrote that was using the records didn't have to deal with it.
Yeah, absolutely.
Right, because you actually broke everything out. So
Absolutely. Absolutely.
and that was actually one of the things, as you were mentioning Eclipse collections, that was one of the decisions we made when we did various summing methods. And it's kind of interesting because I was actually just surprised to look again on like int stream, the sum method actually returns int, which as
On
long
the
as you
int
understand
stream?
that, yeah. But what
Makes
we
sense.
do is like, if you look at our equivalent of int stream, we actually, for our sum methods, we actually return long for int. So we actually widen the result on
Okay.
sum. We do that for floats
Okay.
as well to doubles, but
then it means that you're not associative anymore. That is, if you do sum of sums, since you are summing longs and
it's true.
well, it's a matter of
Exactly. What it's
right?
like, what do you want to give up? Give up on, right?
There's something that you need to give up.
Well, it's funny. It was once again
There's
like
a question. Yeah, Sirisha has a question about the version of Java you're currently using to the audience. Obviously, what I showed you is 17. So Sirisha is using 17 and 11, which is awesome. Congratulations. 17, 11, 8 and 11. They're already. I mean, the amount of people working with 17 at work on the project is begins to show up when I talk to people in jugs, which I do quite regularly. So after 6 months, there are already some projects that have moved to 17, which is really great. Which is really great.
Especially
I think that the
doing,
step. Yeah, sorry.
I was just going to say, especially if you're doing brand new development work, it's just best to just get in with Java 17 and use all the features and use all the benefits that you're getting out of 17.
Absolutely.
Okay. Yeah, 8 and 11 will seem to be the most popular ones. 8 at least, like.
That's. I mean, that's expected. I think.
Yeah. Right.
Probably the step from 11 to 17 is not as big as the step from 8 to 11 because of this module stuff and everything that broke some code because people were not doing the right things. And now in 11 they can't do it anymore.
Right. Or you would migrate to 11 and not look at module system at all. I mean, that's a transition too, which is still a huge migration of its own. So
yeah, absolutely. But moving from 11 to 17 should be much easier than moving from 8 to 11.
Absolutely.
Okay.
Cool. Any other questions? Either you can unmute yourself and ask your question or just ask over here on the chat.
Yeah, feel free.
Feel free to do that. We have Jose here in the house.
I'm going to share the slides once again.
What is it? It's 1:30 a.m. for you now? It is 1:30 a.m. Cool. I mean, if we have no more questions, then we can wrap it up. And you will have, I mean, Jose, do you have your Twitter handle up somewhere? Maybe people can ask you questions separately.
Yeah, maybe you can share the slide with all of your information again.
Yeah, sure. Do you want me to send you the slides? And so that you can share directly, or do you want me to put them on my SlideShare account?
Yeah, you can send them to us, I think, and we'll share right through.
Okay.
Right. So
Sure.
if you already have it in an online format somewhere, that will be the best because we can then just upload it. We can just add the link in our Meetup group so people can access these slides offline.
Okay. Okay, I will do that. I will put them on my SlideShare account. I'm not
Okay.
sure if I already sent because this I modify the slide deck between every presentation. Every time I use them, they are not exactly the same version as the previous one. So
Yeah.
if you really want this slide deck, then I need to put it online.
Okay.
But I'll do that. I'll do that and I'll send you the link. No
Okay,
problem.
awesome. Thank you so much. And we can add that as a
No problem.
comment so you can all, everyone who's attended the call today or anyone else who's just part of our jug can look at that and access those slides offline. So it was a great presentation. Thank you so much once again.
Thank you for having me. It was really a pleasure to.
Yeah,
to be
and we completely appreciate you logging in at what 12
Yeah.
o'clock midnight
Okay.
your time. It's crazy to even think that you're doing this, but thank you so much. We definitely do
Well,
appreciate
it's not midnight anymore. It used to be midnight, but it's not midnight
It
anymore.
used to be midnight.
So that's okay.
it. Used to be midnight. Okay. Yeah. Thank you so much. And you're receiving a bunch of compliments on the
Okay. Yes, I
on
can
the
see that.
status.
Thank you. Thank
Yep.
you so much. Thank you so
Thank
much.
you
I'm
so
glad
much.
you.
And thank you
liked
for
it.
all the new ones and old ones who are joining our session. So please come meet us in
Yeah.
our next jug session as well.